Hey everyone, welcome to this lesson on ETLs. I'm going to make this video narrating through me coding out the lesson. Hopefully, a couple of you commented on how sometimes you feel like you're missing some key details on how functions work in terms of sort of the overall process, or information that isn't necessarily conveyed in the lesson itself via text. And so hopefully by me coding through this and narrating, getting a chance to talk a little bit more, I'll be able to convey some of that extra information that some of you are seeking, and that will help hopefully clarify some of these things. So please let me know if this is helpful on Slack. But for now, we'll just kind of jump right into it. So the lesson for today is wrapping up the ETL with L, right? So we've gone through all these different ways to transform data, whether it's like semi-structured JSON data, or like CSV style flat files. We focused on a lot of extracting. So we were doing all the SQL work where we were pulling information out of databases and wrangling it in some way or another, and then it's sitting there and ready to use via pandas. But so after you kind of do all that stuff, you want to put it somewhere so you can analyze it. And so that's the load part. And so we're going to be doing a simple load today. So hopefully you already went through the other lesson and you set up your database, because you're going to need that in order to actually do this lesson as well as then for the future homework. And so I already went ahead and I have my database created already over on Amazon. And so it's ready to go. So that's already done. And so we'll kind of from there just get into it. So the data set from today is a data set on COVID data. So it's daily testing numbers, or report number in terms of the number of cases, positive cases, as well as the number of deaths. But this is very granular data. So it's by each county in each state in the US. And so the problem is with some of these data is when you have these really granular data is that it's not necessarily useful for analysis right away. It might be too fine scaled, or let's say someone's going to want to do some visualization or graphics with it or something like that. You're going to actually need like a higher level. So, for example, by like state level, people in general might not be interested in county level effects, but they might be very interested in sort of like state level effects. And so you might get a request to sort of make data in that way for visualization or something. There's other issues too with data. So you can have like time series trends, right? And so this can happen in a lot of different things. People are off on the weekends, but they're not but they're working during the week. So you might have different, say, internet website traffic, depending on day of the week or time of day. And we're seeing those trends in COVID cases too. So in COVID cases, the number of positive tests and reported deaths can actually vary wildly throughout the week, depending on sort of when things are reported, when testing's at its peak, when people have time off work, and all these things. And so what it means is that actually like the daily number isn't necessarily the best number to use. You want to instead use like a weekly number, because then this sort of removes any of the weekly trends that happen within a week and allows you to compare like overall week to week patterns. So essentially we need to aggregate this data into a more useful form, into weekly numbers, and then also to roll it up into higher dimension or into sort of a lower dimension. So instead of county level, we want to get it into just individual states. So that's going to be the goal in terms of the transforming. So we're going to extract it from Amazon S3, which means just loading it into our Colab notebook. And then we'll do all of our transforms and get the tables ready to upload. And then we'll actually go through uploading via SQL or into a SQL database. Okay, so extracting is pretty easy. I already have this keyed in here for you. So we're going to call it COVID, get pandas going, and then we just call the data COVID. So you can see this is pulling from my S3 store. So just check the head here. So COVID.head. And so what do you see? So you can see dates. So these are the earliest dates is 122 in Washington, and they're actually zeros. But if you actually did a tail, then you would get the later dates. And so daily cases, daily deaths. So Wyoming has low population density, 4 cases, per day, and then in different counties. And so this is great, but like, does anyone know where Sweetwater, Wyoming is? Like, if you're from there, maybe, but I sure don't. And so it's why overall, maybe knowing the trends of Wyoming as a whole is more useful. Let's do just a describe. So COVID describe. And sorry. So what do we see here? So again, so something's kind of popping out right away is that it's only giving us a describe on 3 columns, meaning that some of those other ones are objects, they're not numeric. That's what it's telling us. And so we can also get some interesting statistics. So we have some negative numbers. We're actually going to not worry about cleaning those up just for now. Those could be for a number of different cases, but overall, we just don't want to go down that path right now, just because it's already a big lesson. What do we see? Max 114,000 cases reported in a day, 455 deaths also reported in a day. Okay, so we have some sad and depressing numbers. Let's go ahead and look at our D types, the data types. So COVID.D types, there we go. Okay, so again, so we see a couple things. So we know that we have this date, but that date is not currently in here as a timestamp. So that's going to be a problem. Other things like counties and states, that's fine. That's an object of strings. And shape, let's just take a look. COVID shape, what do we got? We got 625,000 rows, right? So we have a lot of observations, which is again probably too granular for what we want. So we're going to roll it up, get it to just state level, and instead aggregate these values over the course of the week, and we'll be good to go to upload it. And so it sounds really simple, but actually there's a bunch of little things we have to do because, of course, transforming, as we learned, there's a lot more of manipulation and things like that that needs to happen. But sort of the overall process that we're going to use, we're going to make a date for our date time. We'll aggregate our data, and then we're going to make a unique key that's needed for our database, right? So a database needs a primary key that's a unique identifier for each row. So we're actually going to make one. So let's get started. So you know how this is done, how to make a date time. So we're just going to convert it in place. So we're going to do COVID in quotes date. And what is that equal to? Well, we can use then our pd.to date time, and then call COVID, and then date, run that. And then just do a quick check, like, can we get a min max? Yeah, so there's our min 122. So good, so that worked. At this point, I think most of us should be confident enough in our ability to convert date times. It's sort of a quick check is fine. And I'm also just telling you it's fine here versus needing to go deeper. Okay, so group by and aggregate. So again, so time to group by. So we know we want to group by two levels. Like the first is state. So if we group by just states, it's going to then be able to count up everything that happens in Arizona or Wyoming or California. So that's easy. We know that. We can just call that column. But the other thing that we want to do is we want to group by week. And so this might be a little trickier. Like before we group by year, and you can imagine how sort of if we extract a year number, like 1998 versus 1999, that's really easy to see how that's a unique level. But what defines a week, right? That's a 7-day span that can kind of cross calendar years and has to do with weekdays. And so it's not necessarily like as an intuitive. You could imagine some sort of like rolling function to where, you know, it counts 7 rows within each group as the week, and then goes on to the next or something like that. But you can imagine like anything you have to write yourself, it's really complicated. But luckily, just how sort of Pandas inherently knows the date that something happened based on the number of seconds, it actually also has like calendar information stored. And so what this means is that you can actually group by calendar weeks. And so we can do that with the function grouper. So Pandas has grouper, and so it's a really, really convenient thing for when it starts getting these kind of like weird intervals, like quarterly intervals, for example, if you want to do each quarter of the year, or sort of seasonal things like that. So that's what we're going to use. Is we're going to use PD groupers. So we're going to group by state, and then we're going to group by week level. And then we're going to calculate the daily number of cases and the sum. So I encourage you to play around with this and play around with the different frequencies. But I'm going to go ahead and just code it out here just to tell you, or just to show you. So we want to call this COVID grouped. And what do we want that to equal to? Well, we're going to take our COVID data and we're going to do a group by. And so we know the first level we want to group by is COVID state. And then we want to then group by a second level, which is the week. And so that week, we're going to use the pd.grouper. And then grouper. And so for a grouper, you need to give the key. And so that's basically your timestamp column, right? So what column has your date times in them? And this is we know as date. And then we also need to give it the frequency. So what frequency do we want to group it by? And in this case, we want to group by week. What's actually neat on top of it is that you can actually specify like the day that you want to start the week. So in this case, let's start on our calendar week on Monday. It actually won't make a big difference for this data set, so feel free to, again, play around. You might see some small changes in the numbers, but overall, it's going to be the same information that's conveyed. But so it's up to you in terms of to define that. So we have that, and so now let's do our aggregation. So now we know that we're going to group into calendar weeks and then collapse down into just state levels. And then what do we want to aggregate? Well, let's make our little dictionary what we want to aggregate. So we want to take our daily cases here, and we want to count the sum, right? So we want to know the sum, the total number of daily cases that are happening in each state for each week. So sum. And then we just want to as well, the daily deaths. We'll grab that column, and then colon, and then sum. Okay, so make COVID group for real. So let's go ahead and run that. Pandas groper. Oh, wow. That is definitely not how that is spelled. Grou. Okay. Why am I getting errors? No access name, key, date, freak, week, for object type data frame. So COVID group by. So let's just take a look here. Oh, so the problem that I have right now in terms of my error is you need to feed it a list of values that you want to group by. And I didn't do that. So I need to go throw square brackets around my two levels that I want to group by. Okay, that seemed to work. So let's go ahead and check ahead. Great. Okay, so what we can see here is Alabama, and then you can see this is the start of the calendar week, 316, 323, 330, 46, and then it's giving us a sum number of daily cases and daily deaths. But that actually isn't daily cases, it's weekly cases, and that isn't daily deaths, that's weekly deaths, because we're grouping into weeks. Similarly, we can see another issue. See how they're bold and they're not part of a column? That means they're part of an index. We have a multi-index here. And that might be fine if you are like going to be doing something with this straight away, but we're not. We actually want to have this in those regular columns, not as indexes, in order to upload to our data frame. So we actually want to reset our index, and then we're going to want to do some renaming. So let's just do that. So COVID grouped, and then we'll make that equal to COVID grouped, and then reset that index. So reset index. Whoop. Run that. Let's check the head. Okay, great. So you can see that what it did was it popped these back out to columns. So good to go there. And now we just got to rename. So we want to rename. We can leave this as state and date, but we want to rename this to weekly cases and weekly deaths. So we're going to take COVID grouped and columns, and we're going to make that equal to a list of state and date and weekly cases and weekly deaths. All right, run that. All right, and then we can actually let's just run COVID grouped head. Run that. What do we see? Okay. Cool. So now our column names are sort of in the way that we want them to be. So let's I give you this code. Let's do a quick validation of our data. So we're going to make something called Arizona data. So we're going to take our COVID grouped. We're going to actually filter out a state just Arizona. So let's go here and take a look. Can run this. And so now this should give us just our information from Arizona. Make a quick bar plot just using Seaborn just because it's faster than matplotlib for this. And so you can see that for the date column or date axis here is a mess. But nonetheless, this does very much represent the COVID numbers and the number of weekly cases here in Arizona. I actually went and did also validate these against different sources. So these are very much actually the real data. So if any of you guys are ever looking at New York Times data or MSNBC or sort of any normal website or reputable news website or state level dashboards, you get the same pattern. So we're working with the exact same data here. So we've just replicated those graphs that you see online. But this looks like it works. Everything makes sense. Let's keep going. Okay, so it transforms. So making a key. So now we need to do this thing to where we need to make a primary key. So the whole point about databases is that they're relational. So there's keys within them, and the primary key needs to be a unique identifying key, meaning that no other row can have that key. And so it can be some arbitrary number or string or something like that. But instead, it would be helpful, like if you think about it, to have something to where sort of the key is automatically generated as like a byproduct of the data itself. And so what do I mean by that? So versus like some randomly assigning of a number or even just doing like sequential order, like the problem with those is that if you already, let's say, made a table and now you want to update this in a week from now or a month from now, you would need to go and say, in the case of a random set of numbers, you would need to go and check for each new key that you're assigning that it hasn't already been used, which could be done. It's not that that's that big of a deal, but it's just an extra step. Similarly, if you were using like a sequence, you would actually need to go and get the end of the last element of the sequence, and then anything you upload, you need to make sure that you're starting with that new key. And so instead what we can do is, given we have this rolled up data that has the beginning of the week, well, each one of those weeks is unique for each state. And so if we actually combined the week of the roll up, the start date, as well as then a state identification number, we then have a unique key, right? So there can only be one Arizona on one date in terms of the given statistics. And so we can make a key just from that. And so this takes some wrangling, some string wrangling, but overall not that big of a deal. And then this way we don't have to worry about doing any of these other checks. Anytime we go and update this data, we can automatically generate a key and kick it over to the database without worrying about any collisions of the keys. Okay, so we're going to make a new column called week start. That takes so week start. What it does is it's going to take that date that the grouped week began on and convert it actually back into a string so we can use it. We're going to remove the dashes from it. So we're going to just do some simple string manipulation. We're going to make numeric values for each state in the data set. So, it's whatever Arizona or Alabama or whatever is going to be, 0, 0, and then we'll do 1 and 2 and 3 all the way through 50. And actually there's going to be 53 because territories are on here as well. And then we're going to add that string to the beginning of the data set, or to the beginning of our year, month, day string. So this will make more sense as we go through it. So the first thing I want to do is I want to make my week start column. So I want to convert it back to a string. We remember that we have our as type string to recast data as a different data type. So we need to grab our COVID grouped, and our column is date. And then we want to do dot as type and then string. All right, so we can go and check our data types. And so now we can see we have our new week start column, and this is in here as an object. So that's good. It's a string. It can be manipulated. And so now it's really common to want to remove symbols from a string. So let's go ahead here, and I can actually show you ahead now. So COVID dot head, run this. Okay, so here is our COVID group, sorry. Okay, so here's our week start. You notice the same as the date, but it's just a string. So we want to remove the dashes, just so showing these now so you can see what we can do. And so to remove that, string manipulation, how you do it is you can call your COVID grouped, your column, week start, tell that you're working with a string, and then you can use dot replace. And so dot replace is a way that you can look for certain symbols or certain characters and remove them or manipulate them in some way or another. You can actually see in terms of the instructions here, it's saying replace the old with the new. And you can get very detailed with this and start using regular expression. We don't need to do that. All we want to say is that the old symbol is this, and we want to replace it with a blank, meaning you can just give it a set of parentheses with nothing in it. And so if we run that, what do we see? Well, now our week start is this. So we're basically on our way to a key format to where this is unique. So if we just had Alabama, this week start value is already unique for Alabama. And so now we just need to do that last part of get a code identifier for the state and put it on the front of this. So again, this way what we'll do is we'll have data in a format to where it's a state ID and then this week key, and there's our unique key. So what we want to do is, again, you could go ahead and write a little loop or something to go ahead and assign numbers to each unique value. But of course, pandas makes this a lot easier. There's PD factorize. So pandas factorize. And so I give an example here. So if we make a list of states, say Washington, Arizona, California, those are some observations in it. If you do factorize on it, what it does is it returns an array here. So it returns an array of a list of those 4 values, but each unique value is assigned a number then. And so in this case, Washington showed up first, so it was 0, Washington again, so another 0, then Arizona showed up, so a 1, and then California 2, and it would do that so on down the list, right? And so we can go ahead and apply this to our own data to create a new column. So here I can just show you and just test it out. PD factorize state. So now what we want to do is let's create a new column called state ID. So let's create an ID for each individual text of states. One thing again though, notice how there's 2 elements here. There's the first and the second. So we're actually going to have to call that specific one. So what I mean by that is we're going to go ahead and we're going to do pd.factorize. And we want to call that on COVID grouped. And we want to call that on state. And then we want to grab that first element, right? So it's in the 0 position. And so we can go ahead and run this, but the problem is that it's actually showing up as a numeric, but we want to bind this to a string. We want to actually add this to the start of our string. So that means we also want it as a string. So we're just going to cast it right away as a string type. So as type string. So you could do this in a separate step, but we're just going to go ahead and throw it on the end just to sort of do it in one go. Okay, so what do we have here? State ID now, you can see 0. You can see our week start. And then here we end with Wyoming as 53. Again, we have more than 50 because territories are included in this. Okay, so we have the 2 elements that we need to make our unique keys. And so let's go ahead and join these together. The nice part about string manipulation is that if you actually have 2 columns of strings, you can just add them and it'll bind them together. So I want to create a new column called week state ID. So what this is going to do is it's going to take these 2 values and put them together, and that'll be our unique key. So let's do COVID grouped, and I want to call that column week state ID. Okay, and then I want that to be equal to, and I want the state ID to be first, COVID grouped, state ID, and then we can add on COVID grouped, and then we want to add on what did I call it? Week start, in quotes. All right, and then COVID grouped. Let's go ahead and check it. So here we can see both the head and the tail. So you can see, so this is starting with a 0, and then here's our date string. This is starting with 53, and there's our date string. So good to go. This is a unique key. Now anything that starts with 53 and then the date string, it ensures that it's for Wyoming and at the start of that given week. And so we never have to worry if when we update this, that key will always work. Okay, so make a table of our states keys. So I want 2 tables here. So again, like part of the point of a relational database is that you're eliminating redundant information. So we already have a state ID column that we're going to leave. We don't need to leave the state information in here. That actually should be kicked off into another table to where it's a state and state ID. So this way, if you wanted to join them back together, you could later, but then you're not also having redundant information existing in this database. And normally you would have more in that states table too as well. We're going to keep it pretty simple here just for illustration purposes. So what I'm saying is that I want to create a new table called states to where it's just 2 columns of state ID and state. And so this is pretty simple. So we can call this states. And what we're going to do is we're going to take our COVID grouped, and we just need to grab 2 columns from it, right? So we want to grab states, and then we want to grab state ID. State ID first, and states. Okay, so those are our, oh no, it's just state is a column. Okay, so that'll grab just that. And so what this would do, state ID, plural, okay. So one downside here though is you can see that we have redundancy, right? We have duplicate rows if we don't have this distilled down into week data. So we can actually just drop duplicates, and we can just toss drop duplicates on the end here. And so now you can see that it's just going to give us 1 row for each state and be done with it. So this is great. So now we have a short little states data frame that we're going to upload as a separate table to our SQL database. That'll have information in terms of the actual text, like the state name. So this way we can always figure that out based on a key. Okay. Oh, drop columns. Oh yeah. So now that we sort of have this information out of our COVID group data frame, now what I want to do is just drop those redundant columns. So what I'm saying is I want to drop week start because that's already part of the key, and then also the state name from COVID grouped because those are redundant. So what we can do is just COVID grouped, and this is equal to what? Do COVID grouped drop, and then you can give it columns and then a list of columns. So I'm saying drop week start, and then also drop state. And then look at the head of that. Okay, great. so this is what we want. This has the sort of bare bones information. You could still actually do further rollups in your database if you wanted to, say by month or something like that, or by year, because it's probably going to go on for longer. But overall, it has the information that we need. And I also left data in there just so we can get used to casting or putting up date times into our database. Okay, so pushing information to our SQL database. So we already set that up, and now what we need to do is put these data frames in there. And so there's a lot of different ways to actually add data to SQL databases, and they kind of vary in terms of both the process and sort of like when they're optimal, in terms of like, do you push just one row at a time, or do you do a bash? Do you push a CSV to it? So I'm just going to show you a way to sort of push many all at once, which is a lot faster than pushing single rows, but also it's also pushing from a data frame. So again, there's lots of other methods. Feel free to go and do some Googling to sort of figure out alternatives, but I'm going to give you just one option here. But essentially, there's two databases, or there's two steps to this. The two main steps are you have to define your table and columns and the data types within it. So it's sort of like you're going to make like an empty data frame in Pandas. So you're going to instead go to SQL and you're going to say, hey, I want these columns with these data types, and this column is my key, and these are the names, and blah, blah, blah. And then what you need to do is commit that. And then you also then go and upload your data and commit that. And that makes it publicly visible. This is done using just a SQL syntax. So it's a new syntax, but overall, I think it's fairly intuitive once you get the hang of it. And then, yeah, so let's go ahead and get started. So I've anonymized this. So in order for you to make this work with your database, you're going to need to go and insert the proper host, whatever your database name, username is, and password. I've already run this, so hopefully it should still work. And then also I included the old functions here in terms of running queries or getting column names and stuff, just to sort of speed our process along to give you all those convenience functions. So what should work is, for example, if I do get table names of, just can run that straight away. So states. So we're actually making two tables. You're going to need to make two. I already left my states in here, but I deleted my weekly stats table, which has the weekly COVID rollup. But so you're going to actually have to go and make both. But I left this in there just to this way you can see the queries being operated on at the end. But so these functions are all working and connecting to the database. Okay, so first things first, let's create our weekly table. So to create a table, the function is, or the sort of the start of the string that you're going to give in terms of the actions is just create table. It's nothing more than that. So you say create table and new table name. And then inside the parentheses, you give it a sequence or a series of column names and the data types. And so I already wrote this out here. You're going to have to make your own though in order to do state. So I already wrote this, but you can see again, it's create table, weekly stats. My first column, I want it to be the primary key. I'm saying that's an integer. For the date column, I'm saying I want that to be a timestamp, weekly cases, integer, weekly deaths, integer. State ID, it's already a character in our pandas data frame, and so I'm leaving that as a character here as well. I could upload it as an integer if I wanted to, but you know, we're already working with characters, and so just to leave it as is, and also just to sort of illustrate for now as well, uploading different data types. I'm saying these can't be null, so what this means is that I'm not allowing missing values in this data set or in this table. So we can run this string right here. And so now all we have to do is we basically are going to have to go open up our connection. So we open a connection, get a cursor, we execute this string and commit the changes. So if we go ahead and we do con cur, and that's equal to get, and then concur, right? So we already had that convenience function to get ourselves a connection and a cursor. And so now we have an object called con and an object called cursor. Oh, and we should have made a cursor too. So instead of opening up another connection, oh wait, no, sorry, that made a cursor. Duh. Okay, so now we want to just execute it. So cur.execute, execute. And so we want to execute what? TQ. Right, so I'm calling that table query. So we didn't get a return or an error, so that's good. But in order to actually make this public and visible, we need to commit it. And so you do that actually off the connection. not cursor, comment. Okay, run that. Okay, so in theory, we should have just made a table. So is that table there? So get table names. Fingers crossed, weekly stats. Yay, so our weekly stats table is sitting there. So we now just made another empty table. What are all of our column names? So let's do get column names, because we also still have that. And then table name is equal to weekly stats. Okay, so here we go. So you can see that it made our 5 columns. So yeah. So updating a table. So I actually purposefully made a little bit of a mistake here, just to sort of show you another way that you can manipulate data types within your table. So you already made this table. You could go and delete it and remake it, but you can actually change data types existing. And so what do I mean by that? Well, so you can actually specify different integer sizes to where then a column within your table will only allow for either really big or really small integers. So in this case, we set it as just an integer, and that has this range of, negative 21 whatever to positive 21 whatever. And actually, we're going to max this out. We'll go beyond this value, and the reason for that is that some of our date strings or our keys go beyond this. And so we want to cast this instead as a big integer. And so that will allow us to have the full range of keys present in there. So we need to then change this. So what do I mean by that? We need to alter our table. And so the format to alter an existing table and a column within it is kind of intuitive. So you can just give it alter table, table name. So kind of just how when you select a table name, you have to tell it first what you're going to work with, what columns and tables. Same here, alter table and then alter column, what column you want to update, type, and then the data type to use. So we can write that here. So alter table. And in this case, we want to alter weekly stats. And then we want to alter column. And we want to alter week state ID type big int for big integer. So go ahead and run that. Again, you notice it all in one go. I opened up connection and cursor, got my cursor, got a cursor again. I don't know why I did that twice, given I already had one, but it's fine. Wrote my query, my string, executed it, committed it. Remember before how we actually checked both the column names and the data types? Well, let's do that again here quick. So this is a similar select statement. Remember how the information schema is there, and there's that information that's existing in your database. It's created automatically and updated. And then we also are going to say we want that information from this table name. So we'll just run that, execute it, close our connection. And so this gives us each column along with the data type. So big integer, so that was changed, timestamp without time zone for our dates, weekly case or integer, so on and so forth. So everything's good. We're ready to go. We have our table. We fixed our little error. You now know, or at least have a head start into how to change columns in the future if you need to, or if you made a mistake when making this table. So now make states table. I already made this. This is going to be left blank for you guys to go ahead and actually then make that states table. Okay, so the last step of this, putting information in our database. So we have our empty table. How do we go and put data in there? Well, it's again, you write a string that then tells it, hey, I want to take this table and these columns and insert these values into it. And so it is literally that sort of like verbose. So the main argument is insert into, so that's where you want to put it. And the format is both table name and then in parentheses, how many columns you have. So what column names you want to insert into, and then the values. So what are the data you want to put into each column? This process, again, is typically done row-wise, like one row at a time, which sort of makes sense that if you have some sort of transactional database where a transaction is happening once at a time, it's going to go take this information and kick it off to a database one row at a time. But since we're setting up a database, we actually want to go and do it a big bulk upload. So we're going to do this a little differently. That's going to take a little bit of string formatting. Okay, so what I mean by that when I talk about sort of a single row. So here I took this insert into, and if I wanted to upload a single row of data into weekly stats, I would give it each of the columns. And then, for example, here's the values. Here's our unique key. Here's our timestamp. Here's the number of weekly cases, the number of weekly deaths, and then the state ID. But Otherwise, we'd have to go and do that for each and every single one of our rows, which is a row in a data frame, and so we want to avoid that. And so what we're going to use is instead this execute many, which will allow us to create a string for every single row and execute them sort of all in one go. And so we're going to need to use a little string formatting is all. And so there's some little bit of nuance here, and that we'll get into as we go. But sort of hopefully this will become clear as we go through it, and then you play with this a little bit more on your own. The first thing is that we need to reorder the order of our columns in our data frame to match the columns that are of our database. So if we do, again, what's the order of our weekly stats column? So we can do our get column names, table names, weekly stats, weekly stats. So you can see that these are actually in a different order than what our data frame itself is. And so we need to just quickly reorder this. And so basically all I'm doing is I'm taking and overwriting COVID grouped from COVID grouped, and I'm doing this with by selecting the columns in the order that I want them. So that'll then put this in the order. And then if we did a COVID grouped dot head, what do we got there? Great. Okay. So now the order here matches the order of the data in our database. Okay, first thing to point out, SQL is going to want to receive each data as a tuple. So basically it's like a mutable ordered list of data. And each row of ours is currently a row in a data frame. And so we need to convert them all into a data frame or into tuple, and actually like a series of tuples. NumPy actually allows us to do this really easily. So you've seen a list comprehension where I've used it once before. You could do this with a for loop, but a list comprehension is just basically a simplified version of that. And so there's three main things in here. So we're saying an action. So in this case, we want to make a tuple. What do we want to make a tuple of? X. Well, X is just for each and every element in this last thing, right? So something that's iterable. In this case, if you do this COVID grouped into NumPy, it's going to turn it into an array which it can iterate through. So it can go through and go from position 0 to 1 to 2 to 3 to so forth, each one being X. So if we go ahead and run this, what we'll see here, and we can play around. So what's in data tupes? Let's take a look. Data, sample data tupes. So you can see that each one of these, each row, it went and took and turned into a tuple of information, right? So this is great. So this, you can tell, is actually in the format that we need to match this format, our insert statement. So that's really great. That's what we want it to be. And so you can actually select out if you want to see like an individual element. I think I asked for the third. Position 2. So you can see there's a single one. So that now has converted our data into this tuple format that we need to make our insert string. So now what we need to do is do some string formatting. And so remember how I was showing this operator that allows you to insert values into a string. So for example, if I did something like this, so I have a value here called points needed, and I made 20, and I want to pass that then into here. So say I need to, blank points to pass, and then I do use my percent operator and points needed, it's going to go ahead and give me the string that inserts that value, 20 points to pass. And so we need to make a generalized string that allows us to insert these 5 values into an existing insert string. So we can do that right here. Insert into, we know we want to use weekly stats, and this we can leave static as the weekly ID and date, and the weekly cases, weekly deaths, state ID. You could imagine making this a more generalized thing to where we're also using string formatting and putting our column values in there, our column names, but we're going to skip that for now and just kind of do this manually. But the key thing here is notice that values has 1, 2, 3, 4, 5. So we're creating 5 insert positions for each position of our tuple. So if we go ahead and run that, you can see this is what our string looks like. And so we can test if it's working by trying to add a test tuple into our insert string, right? So if we do IQ and then tuple, or no, what I call it, my tupes or data tupes, and we can say, let's insert that value. Now we went ahead and created an insert string. So with our execute many, what it's going to do is it's going to take this string, and then each and every time we want to give it then this tuple, and then it'll go and make this tuple. So for each row, it's going to actually make the insert string given our tuple and insert and push that to the database. So now we can finally use execute many to push to our database. This will take 2 arguments. Again, the first is a query string, and the next then is our list of tuples. So first, let's get a connection and a cursor. So con cur, use our function get con cur. And then now we can have cur dot execute many. And so we want to execute many versions of our insert query along with data tupes. And then we want to go ahead and cur, and then we want to go ahead and commit that. So con dot commit, and then we'll close. Con dot close. Okay. Okay, so this is going to take a little while. So this is surprisingly slow, even just for this. And so this would be significantly longer if you were doing single row imports or single row imports into the data set or into the database table, because each time it's going to have to go through and open up connection, open up cursor, execute it, commit it, and then start over. And you're going to be doing that in a loop. So it's worth figuring out how to make this execute many work, even if it takes a little bit of the string formatting. Once you figure it out, it actually works really well and it's a lot quicker. So we can then go ahead once this finishes and run a simple query. So hopefully it worked. So it didn't give me an error. So we can do this and go ahead and run a query. Yay. Okay, so all of our information's in there. So week state ID, date, weekly cases, weekly deaths, state ID. Here's all this information. So you can go ahead and run queries. So let's actually go ahead and we can do something. So let's do like a sum. I want to see how many rows are in here to make sure all of our data wound up in there. Distinct, week, state, ID, delete this limit, run query. Sum decimal, that is not actually what I wanted. Oh, because it's in there as an integer. Distinct, let's do, oh, sorry, that was count, that's why. Week state ID. Okay, so count. So what I'm saying is, hey, how many distinct week state IDs are there? So we know that they're keys, so each one's unique. Count up how many there are. 1,770. So in theory, this should go ahead, and I have my fingers crossed that it actually matches the dimensions of our COVID group data frame. COVID grouped shape, no parentheses. Yay, 1,770 rows. So point being is that we successfully uploaded the whole data frame there. Okay, so that's the process. It seems like a lot overall, though. You can see that once you get the hang of it, it's just a bunch of little steps that need to work in conjunction. And with some simple things like some string formatting, you can really automate this to go very, very quickly. The last thing that you're going to do is you're going to add data to the states table. So you're going to go and you're going to make your tuples, make sure the column names match. You're going to make your new insert query and then upload it. I already left that in there so I can sort of like show you how this works. So for example, the first 5 rows of states, and then make sure that the weekly stats are sitting in there, right? So the first 5 rows. And so just as we were doing in previous homeworks, you can imagine, hey, let's do a subquery to where you wanted a query based just off text versus actually having to know the state ID. So what we can do is let's get our weekly stats. We want it from Arizona. So where the state ID is equal to the state ID, and then you're going to go into your states table where state is equal to Arizona. And so Arizona has a state ID of 2. So that's an example of a subquery to where we're using information from both our tables to allow a query based off the text without having to know the state ID itself. Okay, so again, kind of a long workbook here. There's lots of little parts, like I said, you need to make interact. You might make some mistakes trying to get your table up and running in terms of the states table or even your weekly stats table, and that's fine. be sure to go ahead and jump over to Slack and post up the errors that you're having, as well as your code that you're using. So this way we can troubleshoot this together. Each and every one of you will be making your own database as a part of this lesson, which then you're going to be needing from homeworks and for future assignments too. So get moving on this right away. So again, I hope this was helpful. If it wasn't, please give me any possible ways to improve it. Thank you for taking the time to listen.